Hello everyone. I am going to break these slides up into a few videos here. I like to talk about run or control charts and histograms at the same time because often you're using the same data and looking at it a couple of different ways. So we'll go ahead and get started here. So first, what is the difference? So if you remember back to your stats 145 days, so a histogram, you're measuring the variable on the x-axis, and it shows the distribution of data. We're looking for that normal distribution curve or some sort of non-normal distribution, and then we're looking for a root cause for that. Then the run chart shows our data in run over or over time. So our y-axis is our variable, and our x-axis is the order in which the occurrence occurred. So in the histogram, we'll see the y-axis is the number of times that value occurred within that bin, and this is the variable we're measuring: weight, length, height, temperature, things like that, and that variable is measured here on our run chart. All right, so again, histogram, the first one we're going to talk about, we're using that to show the shape of the distribution. We're looking for that normal distribution curve, or we're looking for the variation that caused a non-normal variation or non-normal distribution curve. All right, so how do we build one? We're going to build a very simplistic one. For our example today, we're going to use 5 bins. There are rules about how to set number of bins. You can kind of research that on your own if you want to use these. For today's example, we're just going to use 5. So we need to first find the range. So the range is always maximum minus our minimum. We have all of our occurrences here. There's our maximum and our minimum. All right. So then our range is obviously 15 minus 0 is 15. And our bin width is our range divided by number of bins. Again, today we're using 5. So our range is 15 divided by 5. So our bin width is 3. So our bottom of our lowest bin is going to be our minimum. So our minimum is 0. There you go. Plus our bin width of 3. And our first bin is going to be everything between 0 and 3. Our next one everything between 3 and 6. 6 and 9. 9 and 12. 12 and 15. So there you go. We've now set our bins. So within these bins, now we're going to move all of our occurrences. So we've set up our 5 bins here, and now we're just going to go down the list in our occurrences, and if a value falls between 2 bins, it is going to go in that bin. So 13 obviously falls between 12 and 15, 5 between 3 and 6, 10 between 9 and 12. And in this one, you can see that we're going to use, we're actually going from 0 to 2.999. This is 6 to 8.999, so we're actually going to the bin above. Again, we're working with very simplistic bins at this point. You can see each of these gets moved into the bin. And there we go. That is how you build a histogram. So we've now put all of our occurrences into their appropriate bins. Now we're going to look and see if that's a normal distribution or not. And I think you should all be able to see that we have a normal distribution. We have a equal number of occurrences above and below the center line. We have a nice smooth curve out to the sides there. We'll not get too much into that in this class. Just the basics of reading those. So this is what we end up with. This is what we actually, after we've assembled our histogram, the actual histogram is displayed like this. Again, the variable being measured is on the x-axis, so that is your temperature, your length, the time it took to complete something, any of that. And then the number of occurrences, the n, is on the y-axis. Some non-normal. So this is called skewed, right? So you can either be skewed left or right. So this is where you have the mean and median are not close together. You have more on one side of the median than the other. Bimodal. So this is another fairly common non-normal distribution, and the underlying cause behind that is you have two distinct populations. So this could be something like you have two different machines that are producing the same output, and one machine actually has a larger or maybe a larger die in it. It's outputting the product at a higher temperature, so on and so forth. Heart cut, we see this where we get a sharp drop off. That is any time that you get some sort of filtering. So this is if a product has already been sorted and everything that's above and below a certain measure has already been thrown away. And the opposite of that is called a dog bowl or dog food, where the center has been cut out of it. All right, that's where we're going to stop for this video, and then we'll continue on into the next.